All right, guys. So we're gonna be going over question 11b, and so the question simply asks, compare the energy savings from decreasing the bike frame mass by m compared to decreasing the same mass m in the wheel. If you need numbers, compare the energy saved by decreasing the mass by zero point 0.5 kilograms in the bike wheel or the bike frame when accelerating the bike from rest to 10 meters per second. So to solve this equation, you have to account for both kinetic energy, translational and rotational within the wheel. So here I've written down the equation for rotational kinetic energy, which is 1/2 times the moment of inertia times the angular velocity. And so since this is a sort of a cylinder hoop shape, we get that the inertia is equal to mass times radius squared. And we also know that angular velocity is just equal to velocity over the radius. So we can, in this red bracket, I've gone ahead and just substituted values in our rotational kinetic energy equation. And as you can see, I just canceled out our radiuses because we have a radius squared both in the numerator and denominator. And what we ultimately end up with is 1/2 times the mass times the velocity squared. And then since we have two wheels within a bike, we can go ahead and simply just add them together, or we can simplify it even further. And it's just going to be 2 times 1/2 times mass times velocity squared. And that'll just give us mass times velocity squared. So the total kinetic energy of the bike is just going to be mass times velocity squared, which accounts for our wheels, plus 1/2 mass times velocity squared, which is going to be the translational kinetic energy of our bike frame. And to solve this equation, or to simply answer it, they want to know, which way is better to save energy, taking mass out of the wheels or the frame. And we can use conservation of energy to solve that. Since there's no outside force acting on the system, all we really need to look at is the initial kinetic energy is equal to the final kinetic energy. And since the bike is at rest, we can simply say that the initial kinetic energy is just 0. So what we really want to focus on is the final. Right here, I've gone ahead and plugged in arbitrary values into our equation. As you can see, when we subtract 0.05 kilograms from the wheels, we end up with 995 joules as our final kinetic energy. And when we go ahead and subtract 0.05 kilograms from the frame, we end up with 997.5 joules of final kinetic energy. So when we're going at 10 meters per second, when we take away mass from the wheels, it actually only requires 995 joules versus the 997. So therefore, when we take out mass from the wheels, we actually save more energy when we take out mass from the wheels. I hope you guys learned something from this. Thanks for watching.